Our calculation number 6, we use integration to find the right-sided Laplace transform of the following. So first we have f of t is equals to t sine 2t. So we have t times sine 2t. And we will get the derivative of sine 2t. So we have negative 1. This is negative 1 times 2 over s squared plus 4 dt. So we have a negative 1. We will transfer this s squared plus 4 in upper. So we have times 2 times s squared plus 4 raised to negative 1 dt. Equals to negative 1 squared plus 4 raised to negative 2. So the derivative of this is times 2s. So we have negative 1 times with negative 4s over s squared plus 4 all raised to. And this can be equal to negative 1 times negative 4s is 4s over s squared plus 4 squared. And this is our final answer. Our second problem, we have f of t equals t e raised to 3t. So we have Laplace t times e raised to 3t equals to Laplace of t is equals to negative 1 times e raised to 3t to the limits of 0 and positive infinity. This can be equal to negative 1/3 times e raised to 3t infinity minus e raised to negative 3 times 0. So this is equal to 1. This is equal to 1. Positive 1. This is equal to 0. So we have negative 1/3 times negative 1. And this is equal to 1/3. So this is our final answer. On our letter C, we have f of t is equal to e raised to negative 2t times sine 4t. So we have Laplace of e raised negative 2t times sine of 4t. So we have sine of 4t, and we will put it to grammar limits. We have s is equal to s. Since we have a negative 2, this will become positive 2. So we have 4 over s squared. 4 plus 4 squared is 16. This can be equal to 4 over, we will substitute this. So we have s plus 2 squared plus 16. So this is our final answer. On letter D, we have f of t is equal to e raised to negative t hyperbolic cosine of t. So we have Laplace of e raised to negative t times hyperbolic cosine of t. And then we have Laplace of e raised to negative t and hyperbolic cosine of t is equal to e raised to t minus e raised to negative t over 2. And we have Laplace of e raised to negative t times e raised to t is equal to e raised to 0, and e raised to negative t times e raised to negative t is equal to negative e raised to negative 2t over 2. So we will separate it. We have Laplace e raised to 0 over 2 minus Laplace of e raised to negative 2t over 2. This can be equal to 1/2 Laplace of e raised to 0 minus 1/2 Laplace of e raised to negative 2t. This can be equal to 1/2 1 over s minus 1/2 is 1 over s plus, since we have a negative 2, this will be positive 2. So when this is our final answer. Learnings based on this topic of Laplace transformation, I know how to solve Laplace transformation of sine exponential and cosine exponential functions, and to solve the Laplace transformation of different functions. Through the help of videos given by our teacher, it helps me to improve my learnings and how to solve it correctly.